Imagine instead of using wires to transfer electricity, we do it wirelessly. On one side, I give a 5 volts to a coil, creating a field around it, and the second coil picks up that field and turns it back into power. You can see this exact system in wireless phone charger. But what if instead of 5 volts, I feed thousands or millions of volts into the coil? And instead of a second coil, I place a phone, a calculator, a camera. It could be any other electronic device. As you know, all these devices are made of circuits and wires. They can pick up that field. With this much voltage, we can fry all of them. Engineers call it an EMP, or electromagnetic pulse, and in this video, I'm going to build one. First of all, this EMP device needs a really high voltage generator, so I decided to make a custom transformer. I found this ferrite core and took some measurements. Then I designed a layered cylinder around it. I printed it on my Formlabs printer using clear resin. I really love this printer, it's super precise. And finally, I got this clear print. For the secondary coil, I used a 0.1mm coated wire. To keep track of the turns, I used this tally counter, but instead of pressing the physical button, I took it out and soldered the reed switch in its place. Now I can count the turns just by spinning a magnet. For the first section, I was really careful and won 800 turns. Because if the wire breaks, I have to start all over again. After finishing the first 800 turns, I moved the wire to the next section and did another 800 turns, and then again and again. Anyway, after a lot of neck pain and eating a bunch of candy, I repeat this process 15 times. Done. Oh. Totally 12,000 turns, but I haven't insulated yet. To insulate the transformer, I used epoxy resin, but I didn't go with the usual 1:2 ratio. I actually used less hardener. It takes longer to cure this way, but it completely coats all the wires. I also put it in a vacuum chamber to remove all the tiny air bubbles. And for the primary coil, I want 9 turns using thick wire, and that's it. Now I have 12,000 secondary turns and 9 primary turns. That means whatever voltage I put into the transformer, I'll get 1,333 times at the output. For the flyback circuit, I used a super simple setup with just the MOSFET and the PWM module. Basically, the module generates the signal at whatever frequency I set and sends it to the MOSFET gate to boost it. I powered the circuit with a 9-volt power supply and hooked the output to the transformer. I tuned the frequency to 12.5 kHz with a 70% duty cycle. You have to find these exact numbers through trial and error, and they are unique to every transformer, but generally it sits somewhere between 10 and 25 kHz.
I love electronics. Oof. Again.
Yeah, me and electricity. We are basically a married couple now. For all the circuits, I designed and 3D printed the case. I swapped the old MOSFET heatsink for bigger one. To control the transformer, I added a switch right between the MOSFET gate and the PWM signal. Also for the power source, I used an 8-volt battery pack with a charging port. So far, I've built a high voltage generator, but honestly, that's not enough to create a real EMP pulse. I actually need to something that can store all this energy and in a split second, boom, release it all. So I'm gonna need a capacitor and Marx generator circuit. But what is exactly Marx generator? Imagine I have a weak power source and 6 batteries. First, I charge them in a parallel, and after the full charge, I disconnect them. Now each battery is charged up to the exact voltage of the power source. For the output, I connect them together in series instead. Now my output is exactly 6 times the original voltage. Since we are getting closer to actually generating the EMP pulse, I covered my camera in aluminum foil like a mini Farad cage to protect it from the pulse. And speaking of protection, as you guys know, for this project I downloaded a massive amount of data, 3D file and code every single day. The reality is any of those could easily be infected with malware. Luckily, the sponsor of today's video, NordVPN, completely solved this security issue for me. A lot of people think a VPN just for changing your IP address, but it's way more than that. All those files I download could hide malware that might wipe out my project or compromise my privacy. But NordVPN threat protection feature acts as an invisible shield. It scans and filters the files before they even reach my system. On top of that, when I'm researching new builds, I constantly run into resources that are geo-blocked or restricted in my region. With NordVPN, I have access to thousands of servers worldwide. You can grab the huge discount on a 2-year plan plus 4 additional bonus months using my exclusive link get at nordvpn.com/skillmake or just by clicking the link down in the description. And if you're not totally convinced yet, don't worry because they offer a 30-day money-back guarantee. Alright, let's back to the project. Now, instead of batteries, I'm using these 15 kV 2 nanofarad capacitors. Also, to get even more power, I soldered them together in series. But instead of just one, yeah, I needed of them. I lined them up to next to each other and used these resistors to build the parallel path I want. If your electronics are solid, let me know in the comments why I put these resistors between the capacitors. The parallel path is ready, but you can't have a parallel and the series connection at the exact same time. But Marx used a really clever trick. Instead of using solid wires between the capacitors for the series path, he used spark gaps. So now the transformer charges the capacitor in parallel, and the moment they are fully charged, they unleash their energy as a spark. And that's exactly what creates our series path between these two pins. Let's test it. Yeah, I think I know why it's not working. A Marx circuit actually works with DC voltage, while my transformer outputs AC. Luckily, solving this is the easiest part of the whole project. I just used these high voltage diodes to build a bridge rectifier and added it straight into the circuit. Can you see these sparks? They are exactly what creates that series path I was talking about. To finish it up, I packed the entire circuit inside the case, leaving only the 2 high voltage outputs sticking out. Now the only thing is left winding the coil to actually generate the pulse, but there are a few crucial details here. First off, the shape of the coil itself. Usually everyone winds these in a standard cylindrical shape, but I found something way better. The pancake coil. I actually analyzed the magnetic field for both. With a cylindrical coil, a large part of wave just stays trapped inside the cylinder. But with a pancake coil, the pulse is literally shot straight forward. The second point is I only want the pulse to travel in one direction along the coil. In fact, it naturally generates in both directions. Well, I actually found the solution in this wireless charging module, specifically this fridge shield behind the coil. Look at this. Right now, the pulse is focused on one side to charge the phone. But if I flip it over, the pulse actually can't pass through the metal. And that's exactly the point. Metals block the pulse. So keeping all these points in my mind, I finally added these pieces to it. A pancake coil with a metal shield right behind it. And for the first test, I tried it out on my digital caliper. Well, I've always hate math, so I think it's time to destroy this one too.
Dios!
Don't worry.
Next up is this, my lovely Apple Watch. It's worked perfectly and it's in a great condition, but it's a fake. Next up is my old monitor. It works perfectly, but just for you guys.
See you in the next video. Bye bye.